we're going to talk about what percentile is. So let's consider the sample of observations. There's these 5 observations from 23 to 118. And we have to understand just what percentile would mean over here. Let's look at this as a scenario where these are marks of 5 students, and the paper was of 120 marks, and this is what they have scored. So the percentage that this student has would be normally 118 upon 120 in 100. So I'm assuming that's somewhere like around 98 or something, like really a really good percentage, or maybe even more. I think it'll be more if we just see like, okay, I'm clearly bad at math. Yeah, 98.3. Wow, okay, I'm not that bad. Okay, yeah. So that would be his percentile. Oh, sorry, percentage, right? 98.3%. So this is the percentage. But as we know, like percentile of the student is 100 percentile, because he is like the maximum scorer. So he is setting the bar. He has stopped it. So this is 100 percentile. And this guy over here has he comes in the lower part of it. So you understand that 100 percentile means there is nobody above him. Now if like x value is, okay, forget that arrow, not helping. Okay, now if we want to find the 95th percentile, okay, this is 100 percentile, 100 percentile. If we want to find the 95th percentile over here, that basically means the marks that a student must get in order to be in the top 95%. Like there is 95% people below him, below those marks. Okay, I hope that is clear. So this is the concept, and we're going to look at the formula that basically helps us find these percentiles. So let's take a look at this question over here. Basically, we have to find the 10th, 50th, and 100th percentile in these marks. So what are these? What are the marks like that are 10th percentile, 50th percentile, and 100th percentile? Okay, so let's get started with this very simple rule. So the rule goes like this, that n is equal to the number of observations. Okay, so in this case 5. Okay, and p will be the percentile, that is p will be the percentile upon 100. So if we consider case 1 to be 10th percentile, if we want to find that, then it would be 10 upon 100. So that would be a simple 0.1. Okay, nothing confusing till here. Now what you have to do is you have to find NP. So NP in this case would be a simple 0.5. I hope that's clear. Okay, now if you look at NP, if it is an integer, you do something, and if it is not an integer, you do something. So in this case, in our case, it is not an integer. So what we're going to do is, this stands for not, okay, not. The smallest integer greater than NP will be the term that is the required percentile. So over here, 0.5, and the smallest integer above it is 1. So the first term will be the 10th percentile. So this is your 10th percentile, okay? Similarly, let's solve for the 50th percentile and the 100th percentile using this formula. So let's go back a few steps so that we can start afresh. All right, so here we have our 50th percentile. So that would be a 0.5, right? 1 by 2, yeah. And 0.5 and a 5 would be 2.5. And then again, we have the same case. So it would be 3 and the third term. So this would be the 50th percentile. So this is 32, this is 23. And now coming on to the 100th one. So here, if we replace it by 100, that would be 1. So NP would be 5. I'm sorry if this is a bit messy, but like, I hope you understand. Okay, 5. Now 5 is not an integer, it is an integer. So 5 falls in this category where it is an integer. So the 5th term is the required percentile. the fifth term, which is rightly so, the fifth term being the percentile, right? So this is your 100th percentile. So that's how you solve this particular question. This particular, I hope you all understand what it means. Now, while doing this, I have a doubt. That is, shouldn't this be like the 0th percentile? Because there is 0 people under him, like below him, whereas there's like 100 people under him. But again, if you see that it's not really 100, it's 5. So if 100% stands for 5, no, but still 0% should always stand for 0 people below. So it should always be this. Like, shouldn't this be like the 0th percentile or something? So why it is not the 0th percentile is something that we should find out. But otherwise, our formula works very properly. With that, if we wanted to find the 0th percentile, let's do that. So 0 upon 100 would be 0, NP is equal to 0. So 0 is an integer in itself, and that's not a term. So I think it's always like 0, right? I mean, I don't know, honestly. Yeah, so this is a little confusing. Now, if we wanted to find the 1th percentile, how would we do that? I mean, we would do it the same way, percentile upon 100. So that would be a 1. I will erase a few things, or else let's just solve it in a new way over here. Okay, so the 1th percentile. Okay, 1th percentile of, I'm assuming I have something. Yeah, so this is what we're looking at, right? From the start, this has been our data. So we have to find the 1th percentile. Perfectly makes sense. Okay, so I hope you guys can solve this with me by now. What we can do is we can make this little table that helps us understand what we're doing. So P over here would be 1 upon 100. That would be 0.01. Perfect. NP would be 5 into 0.01. So that would be 0.05. Amazing. And the term. So over here, this would again be the first term, right? I mean, technically speaking, the smallest integer greater than this. So for the first term, so the first percentile, according to this formula, if I'm not wrong, is 23. So if any of y'all are experts in this particular domain, please help me with this, because how can the first percentile and the 100th percentile be this? I mean, the 10th percentile be the same, okay? And why is it not the 0th percentile? Because like, if this is the 100th, this should be the 0th. Also, another thing that we're going to talk about is how to find this number is what percentile. What is the percentile of a particular number? Okay, so I think how we would get this is by back calculating a little. What we would do is pretty simple. Okay, so I'll use another marker over here. The term. Okay, so let me erase a few things. I despise you. Okay. Okay. Amazing. You can fast forward this here. Okay, amazing. Now going back to this thing. Okay, so the term over here is 2. Okay. So NP. Instead of doing NP, let's give this a variable T. Okay. So in order to find NP, I mean, P is what we have to find over here, right? We know N. Now, generally speaking, NP is equal to T, or NP is less than T. So less than equal to T is like a generalization. So over here, NP is less than equal to T. So P is less than equal to T by N. Amazing. So far, so good. 2 by 5. Okay, so that is 0.4. is P. So P is less than equal to 0.4. So now in the ideal case, for us to like get a proper thing, so this would be a 40 percentile, since P is equal to percentile upon 100. So 0.4 we would get a percentile equal to 40 percentile. So we have successfully found this. So this is the 10th, this is the 40th. If there's any more confusion, we will look back at it. But I think that this knowledge that we have, this particular rule, and I mean, this rule is the most important thing. It's gonna help you solve the questions that will come. So I don't think you'll have any difficulty in solving questions. Conceptually, you might have a problem over here, or we might be doing something wrong over here when it came to the whole 0.05 thing, and the way we took it 1, and even with 0.5 being 1. I don't quite get it. Okay, so yeah, I think that is a little point of confusion, but I hope this is pretty clear to us. Okay, thank you. Bye.